Okay, so now we're going to move on to some word problems. This is 7.3. Word problems related to quadratics. And basically, I'm just going to be giving you a graph, and this is kind of what you have on your CPT. You have a graph, and then you're going to be asked different information about that graph. So if we look at the first one here, the graph shows the path of a soccer ball that's being kicked. The horizontal scale is in time. Since the ball was kicked, the vertical scale is the height above ground in meters. So the horizontal is time in seconds, and then the vertical is the height, and that's measured in meters. So obviously we've got a soccer ball on the ground. When we kick it, it goes up in the air. It reaches this very important point, which we call the vertex. And then what goes up must come down. Okay? And we're going to assume that all of these are just by 1. So 1, 2, 3, 4. The same thing over here. 1, 2, 3, 4. And now we'll go ahead and answer the questions. How many seconds after it was kicked did the ball reach its maximum height? So first of all, we have to identify what the maximum height is, which is a part of our vertex. So the maximum height is at 3 meters. How long did it take to get to that 3-meter height? It took us 2 seconds for that ball to reach that height. What was the maximum height that the ball reached? We said that that was 3 meters. It was able to reach a height of 3 meters. For how many seconds was the ball in the air? So what was the total length of time that the ball was up in the air? Ball goes up, ball comes down. It took 4 seconds for the ball to go up and then again hit the ground. So this horizontal axis is the ground. The height is the air above the ground. It's that easy. Okay, we're going to go through a variety of examples, but ultimately what I'm looking for are the x-intercepts, the y-intercepts, and the vertex split up into usually the axis of symmetry and the max or min value. So let's look at another example here. Sam rides his bicycle down a ramp from the top of one side to the bottom and back to the ramp on the top on the other side. The parabola models his height in feet above the ground compared to a horizontal distance in feet. So both of these are dealing with our height and our distance, and they're in feet, which is a unit of measurement that we learned last time in Unit 1. So how high is the ramp? The highest point of the ramp is 30 feet. How wide is the ramp? Goes from 0 to 60. How high is Sam when he has traveled a horizontal distance of 50? So if I go a horizontal distance of 50, let's see here. Here's 50. How high up am I? Come across. I'm between 10 and 20, so that's 15. So if I'm at a distance of 50 feet, I'm at 15 feet up in the air on the ramp. Okay, so we're basically just going through and reading parabolas. Let's look at another one here. The graph models, and this one's going to be very similar to the one that's on your CPT, so it's important that we pay attention to this one. The graph models the path of a basketball after it was thrown from a player's hands to the basketball hoop, through the net and down on the floor. The h values represents the height of the ball in feet. So h is my height in feet. And d represents the horizontal distance from the player's feet. So the distance from the player's feet, and it's measured in feet. So really what we can imagine here, to make our lives a little bit easier here, is that we've got somebody standing here. This is where my feet are, or the person with the ball. They got their hands up, and they're holding the basketball. Then the basketball goes up, comes back down. Now it's very different than a soccer ball because a basketball, you're holding it up in the air, while a soccer ball is down on the ground. Again, we have that very important point that we're going to point out for ourselves that has an x and a y value, and we call that the vertex. So now we're going to go through and read the questions here. What's the height of the ball when the player first releases it? So the player's holding it at 5 feet above the ground when he first releases the ball. What is the maximum height the ball reaches? Well, the ball manages to go up to a height of 14 feet above the ground. How far from the player is the ball when it reaches its maximum height? So in between here, if we look, every block is going by 2, 4, 6, 8, 10. So we're at 10 feet away from us when it reaches that maximum height of 14 feet above the ground. If no one touches the ball, how far will the ball be from the thrower when it hits the ground? So again, we'll go look at our graph. We'll zoom in for a second here. It hits the ground if every block goes by 2, so 20, 22. After 22, it'll be 22 feet away from the player when it hits the ground. Now on this next page here, 3, 4, and 5, we're dealing with pretty much the exact same style of questions, right? How tall, what's the maximum, how far away is it, how long did it take? So really, I want you to go through these on your own and then check your solutions against the filled-in version on our Google Classroom platform.